Ladies and gentlemen, my name is Sarah Cho, and I will be presenting my CS 584 final project, and the Oscar goes to... So, the objective for my project is to accurately predict the winner of the Best Picture Oscar using nomination data from other Oscars and nomination and winner data from the other precursor awards. So before we get into that, a little history about the Oscars. The Oscars started in 1929 to recognize the growing merits in technical and artistic achievement in the Motion Picture Academy. And originally, 5 films were nominated each year for Best Picture, and it eventually grew to 8 to 10 films. So the Best Picture Oscar has a direct impact on film studios and movie theater profits. It can bring as much as 30% increase in box office revenue, and it can help a studio's reputation in the industry when they are a new studio and trying to establish themselves. It is also the most important award given in Hollywood, and has very much a history of surprises. As you can see by everyone's reaction here, things did not go to plan. And this was specifically from the 2017 Oscars, where La La Land was declared the winner. However, due to an envelope mix-up, the winner went to Moonlight. Upsets can occur, and with my prediction program, we can forecast these upsets happening a little more accurately. So 2 of the data sets I ended up using were the Oscar Awards and the Screen Actors Guild Awards. I also used additional data from the Directors Guild Awards, Producers Guild Awards, and the Writers Guild Awards. I reformatted and merged everything into one data set, and each row in the data set has the year and the name of the film nominated for Best Picture for that year. And the data set contains 179 films covering 27 years of awards. So the first version of the data set had about 12 award attributes for X, and each attribute had a value of 0 or 1, indicating if the film was nominated for the award. Y is represented by a Boolean value in the Best Picture column. And after initial testing, number of award attributes were expanded. So some of the categories I included were Best Director, Editing, Screenplay, Actor, Actress, Supporting Actress, and Supporting Actor. And the precursor awards I used were the Screen Actors Guild Award for Cast in a Motion Picture, the Producers Guild Award for Theatrical Motion Picture, the Directors Guild Award, and the Writers Guild Award. This is the original dataset structure, and you can see which categories received nominations and which did not. So for the first run, I used a random forest classifier model and all 12 features in the dataset. My training set spanned from 1994 to 2015, and the testing set was 2015 to 2020. The model treats each value of X as independent, so it does not always find a winner in that year group. Therefore, the success of the model is dependent on the number of true positives rather than accuracy. The films are output in a year group, and the program selects the film with the highest probability of true as the winner for that year. I also used Eta Boost, Naive Bayes Bernoulli, Naive Bayes Multinomial, and K Nearest Neighbor. The Naive Bayes Bernoulli performed the best, correctly predicting 3 of the 5. And you can see this in the results using feature set 1. I then decided to apply feature selection to improve model accuracy and created 8 different feature sets using the original data set and added 6 more feature sets using additional data about winning precursor awards with 14 different feature sets total. And here are the feature sets that I chose. And here are the results using Naive Bayes Bernoulli with the results on the test set. So overall, set 11 performed the best. And these are the categories I specifically chose for set 11. It was the Editing Award, which is most common nomination received by all Best Picture winners since 1994. The Directing category, Cast in a Motion Picture, was very important for Screen Actors Guild, and so was getting a screenplay nomination. Having a good cast and story are crucial to Best Picture winning movies. Theatrical Motion Picture Producers Award, and a victory in the Directing category. So for this year, my model is going to predict Nomadland, and for the feature set, it gave it an F1 score of 0.67 and a probability of truth of 0.7. And when I oversampled this information, I ended up getting a result for F1 of 0.85 and a probability of truth of 0.92. And in the future, I want to expand this program to include the Acting, Directing, and Screenplay Oscar Awards. Thank you for coming today, and I hope you have a wonderful evening.